Hello, my name is Imanrullah Bin Hapizal. I am from Session 2 of Semm 3253 Mechatronics from Session 2020 and 2021. And today I will showcase my project, which our group's theme is Smart Parking System. And I will show you how it works. If you go into a shopping mall, for example, there will be no way to know if a parking spot is available or not. And you will be wasting your time looking for a parking spot, driving back and forth on each floor level even though it was already full of cars. In order to combat this issue, we need to build an automatic smart parking system which can indicate to you where a free parking spot is available from afar, an automatic gate system, and a safety indicator so that you can safely park your car. So firstly, I will tell you about the main components inside my system. So for the analog sensor, I will be using ultrasonic sensor. So for this project, the ultrasonic sensor will be used to measure the distance between the car and the parking slot. So for the next sensors is the digital sensor, which I will be using infrared sensors, or better known as IR sensors. So for this project, there will be a total of 3 IR sensors. So 2 IR sensors will be used at the gate, and 1 IR sensors will be used at the parking slots. So for the analog output, I will be using LEDs. So for the other components in my system, we have Node MCU, ESP8266 for the brain of the whole system, and the servo motor to be used for the gate of the system, the MB102 breadboard power supply to supply power supply to the entire system, 1 kilo ohm resistor so that we can regulate the voltage into the LEDs, the breadboard so that we can connect all the sensors into one settings, and the jumper wire to connect the sensors to the breadboard. Now, I will explain how my system works. From the Blink app, we can open or close the whole parking lot. For example, when the parking is open shown, this means that the cars can enter the facility, like so. However, when I press the button and it shows the parking is closed, no car can enter the parking lot, like so. So I will turn on it again and we show the parking is open. When the car approaches the gate, the first IR sensor will detect the car, and this will initiate the servo motor to open the gate. As we can see from the parking spot, the green LED is shining brightly, indicating that the parking spot is available from afar. When the car is approaching, this will be detected by the ultrasonic sensor. As we can see, when the car is moving closer to the ultrasonic sensor will calculate its distance. So this when the car is moving away from the parking spot, and this is when the car is moving towards the parking spot. When the car is closing in, the green LED will start to dim, and it will blink slowly. Then the green LED will start to blink rapidly as it approaches, and then the red LED will start to blink as well. When the car is safely parked, the red LED will shine the brightest, while the green LED will be completely shut off, indicating that the parking spot is taken from afar. When the car is parked, the IR sensors inside the parking spot will detect it, and it will send the data to Blink. As we can see from the Blink, it said the parking available is 0. When we remove the car, the parking will be 1 again. So let's see when we put the car back in again. We can see the parking available will become 0. When the car is moved outside the parking spot, 2 things will happen. 1. The IR sensors will no longer detect any car inside the parking spot. Hence, the parking available will be back to 1. Then, the LEDs will act the same as before but in reverse, where the LED will start to dim and both the green and red LED will start to blink. And the green LED will shine brighter and blinking slower. And lastly, the red LED will be completely shut off, leaving the green LED to shine brightly, indicating that the parking spot is available again. When the car wants to go outside, the second IR sensors will detect the car and it will open the gate. So that is all for my system. Thank you.